as you want if everyone can get through the regions. How about that? Yeah, you can just put that thing on replay for 43 minutes for all I say if we can all get through the regions.
I want to see all the dorky guys on stage. I want to see the stupid yo-yos.
All right, here you go. One of the two toughest units we have to offer. The next one's coming up after this one for probability. Let me give you a couple of things to keep in the back of your mind for this unit. Never should we have a negative answer. Why? You can't have a negative 10% chance of something happening. Okay? Should never have a negative answer. Also, should never have an answer that's bigger than 1. You can't be better than 100%. Okay? Can't be better than 100%. So what am I trying to tell you? All your answers here in this unit are going to be somewhere between 0 and 1 when it asks for the probability. What's a probability of 1? Everyone familiar with the die? 6-sided? Okay, what's the probability or the chances I roll a number between 1 and 6? 100.
100%.
100%. That's 1. That's a probability of 1. 100% chance. You can have a probability of 0. What's the probability I roll a 7?
0.
It's not happening.
Because it's not on the dice.
It's impossible. So we say that's got a probability of 0. And then everything in between. Okay, so no negative probabilities, nothing bigger than 100% or 1. Okay, if we're getting that, something's wrong. All right, let's hop right into it. Please stop me if anything sounds a little confusing, because I'm going to go through a lot today over the next 3 days. All right, very basic probability. I have a spinner that's divided up into 6 slices. All right. I always like a visual. Whether I write out all my possibilities or actually, hey, here's my spinner. 1, 2, 3, 4, 5, 6. It doesn't have to be anything great. Or if you just want to list out the numbers 1 through 6. Either way, I got to see some type of visual so I know what my outcomes could be. What's possible here? So I'm asking first one, what's the probability I land on a 4? Okay, probability I land on a 4. Before we answer that question, we got to make sure we are able to understand and recognize the shorthand in this unit, because I don't want to have to write this out all the time. Instead, what I like to do is put a capital P, which stands for probability, and then I'm going to put a set of parentheses with what I'm looking for inside. So that's me saying, what's the probability I get a 4? Shorthand. All right, because I'm not writing out all these words all the time. So that stands for capital P, probability I obtain a 4. All right, and I know most of you probably can answer this very quickly, but just let's slow it down. How many choices do I have on this spinner? There's your denominator. How many possible choices you have is always your denominator. Numerator is how many of them are what we're looking for, which is a 4. There you go. So you have a 1 out of 6 chance. In between 0 and 1, right? That's in between 0 and 1. That's what all our answers would be. So 1 out of 6. Any issues there? Because that's the only time I'm going to spend on something as basic as this. All right, sometimes you'll have the word not with it. So this next one, what's the probability you not have a 4? So probability not a 4. There's still how many outcomes, chances? 6, right? 1 through 6. But now I want how many of them are not a 4? Don't answer. So out of those 6, how many are not a 4? Let's hear from number 12. 5, right? 5 out of the 6 are not 4. No issues yet. Pretty standard. Any questions? All right, now let's get a little bit more complicated. Still at my spinner, 1 through 6. So my diagrams on the other slides. Let me just write out 1, 2, 3, 4, 5, 6 here, so we're good. Now, what's the chances or the probability I get a number greater than 3 and even? And, meaning both have to happen. Both. So I get a number that's greater than 3 and it's even. Still out of 6, right? So I look at my choices. How many are greater than 3 and even? And, don't answer. Both have to happen. 18. Greater than 3 and even. Which choices? Tell me just which choices so we can see it, Nora.
4
4 and
and 6.
6. Everyone agree? Those are 2 choices, so 2 out of 6. I don't care if you reduce it or not, but I am going to warn you. If it's a multiple choice question, it will be reduced. So I would just get in the habit of 2 over 6 or 1 out of 3. Because you're probably going to see 1/3 as a multiple choice and not 2/6. Any issues? Same question now, number 4. Same exact question, except now I change the and to an or. Okay, what's the probability I get an even or something greater than 3? Still out of 6. Now watch. Watch this here. Let's do this one together as a class. How many are even?
3.
No, it's just how many.
How many are even? Or I could have even, or I could have greater than 3. Ready? Greater than 3.
There's only 2.
So
Oh, 3.
Right? All those numbers I've just underlined are even or greater than 3, right?
Yeah. So isn't it 4?
Well, here's my question. Is it 4 of them, or do I count the 4 twice and the 6 twice? No! I don't count a number twice. Guys, do you see how the number 4 is even? And do you see how it's greater than 3? But I only count it once. So how many total numbers fit my description here that they're even or greater than 3? 4 of them. I don't count the numbers twice. Is everyone all right with it? That's going to be a huge thing today. With an or probability question, I cannot count the same value twice. And if you want to reduce, 2/3. See the difference between and it's got to be both of them. And an or it can be either one. And I don't count the same thing twice. Anything you want to ask? We got to take a breath here because this next one's going to blow some minds. Questions? All right. This is probably the first time you've seen these type in probability with the word given in it. Given. Ready? So what's the probability of getting in a number greater than 3 given it's already landed on an even number? First thing, before I even answer it, symbol notation. I'm going to rewrite this. Probability greater than 3. Everyone ready? Here you go. Greater than 3. Everyone see this vertical line here or a little slash? That is the mathematical form for writing the word given. Right there, given. So greater than 3, given, it's even. That's how I write it in shorthand. I write a little vertical bar. Okay, ready for this? Everything has been out of 6, hasn't it? Until now. This will not be out of 6. Here's why. Ready? Probability greater than 3, given we already know what? It's even. We already know my number's even. So I don't have 6 choices anymore. How many do I have? 2, 4. I only have 3 choices now. I already know. Given, it's even. I already know my number's going to be even. So that's why the 6 reduces down to 3 choices. We okay? Now, out of those 3, how many are greater than 3?
2.
So there's my probability, 2 out of 3. Okay, so the size changes when I'm given something. All right, I already knew it was even. So 1, 3, and 5, out. It's only going to be 2, 4, or 6. And that's only 3 choices instead of 6. Questions? That's going to be a tough one for us. And we got to do a lot of reps on that one. All right, let's go. All right, we're going to do this all out now. So I got a fair coin. Everyone familiar with the coin, heads, tails? I'm being serious. I'm not, being sarcastic and being a comedian because some people don't, thank God we're not going to have a deck of cards in this unit because That's like a day in itself, teaching the deck of cards. And a 6-sided die. All right, 6-sided die. We're going to flip the coin, roll the die. What I want to do first is, can you help me write down all my possibilities before I start answering anything? What are my possibilities? Flip the coin, I could get a what? Okay, ready? Heads, and then I roll the coin, I could get, let's say I roll the die, I get a. Okay, let's say I get a 1. So one possibility is heads and a 1. See where I'm going here? What's another possibility? Heads and a 2. We good now? Heads and 3. Heads 4. Heads 5. Heads 6. I always like just to write them out, especially if there's not a lot of them. I like to just see what my choices are. And then what else do I have to still do? T1, T2. All right, so there are all my choices because it makes it a little easier to answer these questions. First thing I want somebody to tell me, we're going to write all these out in words. Okay, so I have all the symbols for you. I want them in words now. Okay, so we know exactly what I'm asking. What's number 1 asking for? pH. pH, what's that saying basically? 6, what am I asking for here?
Possibility of getting heads.
Yep, probability of getting heads. Okay. How many choices do you guys have? How many choices do I have?
6.
Total. I'm sorry. I'm talking denominator here. 12 choices. How many of them are heads?
6.
Okay. But yes, that reduces down to 1/2. And yes, flipping a coin, 1/2 for heads, but I want to see where it comes from with all my outcomes I wrote down. You ready? Next one? Any issues there? What's the next one asking for? In your own words. What's it asking for? 5. What's 2 asking for?
Probability of getting tails of a 2.
Good. It's got to both happen. Both got to happen. So probability of tail and a 2. Both got to happen. Both. Not one or the other. Both at the same time. So when does a tail and a 2 come up? For how many times?
1.
Yes? Right there. T2. Out of? Okay. Okay. Tail or, never mind. Well, I'm not going to ask. I just gave that away. Probability of tail or a 2. Different question. Different question. It's not going to be the same answer as number 2. Or is big. Okay, ready? Go through the list here with me. I know this is very elementary schoolish, but it gets the job done. H1 work?
No.
H2?
Yeah.
I heard some no's and some yes.
Yes.
Why? Because it's or a? There you go. H3? Any of the rest here? Okay, and what about there?
Yes.
Now watch. T1 because it's a tail.
Yeah.
T2, do I circle it? Do I count it twice because it's a tail and a 2? No, only count things once. So how many choices do I have? Not 8, 7. 7. All right, I don't count T2 twice. 7 out of 12. All right, you ready? Ooh. Now it gets tricky here. How do I read this? Look back if you need to remember what the slash meant. How do I read number 4? 7. How do I read number 4? What's this? Given a 2 has already occurred. 2 has already occurred.
What does that mean?
That means I've already rolled a 2 on the die. And because I've done that, now look, because I've already rolled a 2 on the die, I don't have 12 options anymore. I only have
2. So you
I've already rolled a 2 on the die. These are my only ones that have a 2.
Oh, wait.
So I don't have 12 options. I only have.
I was thinking it was everything but the twos. That's why I said.
I've already, guys, hear me. You've already got a 2. I know there's a 2. So that gives me 2 options. What's the chance I get a tail out of those 2 options?
1.
Everybody good? Okay, sorry, I'll rewrite that. There we go. Ready for the next one now. Let's reverse it. Probability of a 2 if I already have a tail. I don't have 12 options anymore. What do we already know happened?
We already have a tail.
Nope, you got tails.
Given what?
Tails. 6 options.
I have 6 now options, correct. And out of those 6 only, how many have a 2? All right, we're getting this now, this given stuff. Okay? When you hear the word given, it happened already. All right, so my chances, my denominator is going to go down. Any issues? Okay, so now we work with tables now to find our probabilities. All right, our tables. Well, first we got an issue with our table, don't we? It's not complete yet. Can we help me complete it? Help me fill in some of the totals. Let's see. Let's go over 14 years old. How many people are over 14 years old total? All right, good. How many people are over 5 feet total? All right, and if you guys were just adding up the columns and rows, and it doesn't matter if you add up the row or the column, how many total people are in here? 100.
100.
All right, so now let's answer questions based on a table. What's the probability a person will be under 14 years old and over 5 feet tall? Let's not yell anything out. So it's and. I see and. So it's both of these have to happen. They have to be under 14 and over 5 feet tall. So there's only really one spot on this chart I'm looking for. And how many children or how many people fit both?
12.
1. How many people fit both here?
12.
12, right? Nope. I don't think 12.
Oh, sorry.
Under 14, over 5 feet.
Okay, so 9.
Right here, right?
Yes.
Everyone agree? 9? Everyone see where I found the 9? But my answer can't be 9, right? That's way over 1. That's never going to happen. Probability 9 out of your total 100. Yep, and I can't reduce that. Okay, how are we doing so far? All right? All right, go ahead, Emily.
It wouldn't be the. Never mind.
All right, ask if you have it. Anybody? Okay, 2. A person chosen will be under 14. Under 14. What's the chances I pick somebody that's under 14 years old? And that would be how many people? 9. How many people are under 14? 30. Out of?
100.
There we go. Still 100. Anybody reduce that real quick? 3 out of 10. Yep. Ooh, here we go. Now it's going to get serious. Focus in, buckle up. Find the probability someone's over 5 feet or they're over 14 years old. Let's do this one as a group. How many are over 5 feet?
67.
Total, 67. Plus the ones that are over 14. How many are over 14? 70. But I got a problem.
That's more than 100.
There's people that I counted in the 67 that I also counted in the 70. I can't count them twice. Plus, add those up. What's the issue? Yeah, it's going to be over 100. So let's get real. That can't be my answer. I need to subtract out the people I counted twice, which are how many were over 5 and also over 14? 58. Does everyone see I counted these 58 people 2 times?
Yes.
So I need to subtract out the 58. So my final answer here, 79 out of 100, and that cannot be reduced. Anything there? Why? Any or question, you've got to remember, I got to subtract out anything I would count twice. Last one with the table. Probability I choose a person over 5 feet tall. Oh, there's that word. Given the person is over 14. So we're not out of 100 anymore, right? What do you guys already know happened?
The person's over 14.
Okay, which means how many people am I choosing from now? Thank you. There's your denominator now. 70. I already know they're over 14. Now, from that 70, how many are over 5 feet? From that 70. Look at the table. It's 58. Great job. And just to let you know, 29 out of 35. Your calculator reduces for you. Specifically with number 4, any questions with the given? Remember, your denominator is going to change. All right, last thing. So now, go ahead, Sarah. Sure. No, not in this case. No. Sarah, I just want you to be familiar with, if you see it, you know exactly what I'm asking for, okay? All right, so we did it from a table. Last thing we got to find probabilities of is, anybody seen those before, huh? What are those? Venn diagrams? Yep.
Those are like really.
Don't answer any questions yet. What do those 4 numbers mean? That's what I want to do with you first. What do those 4 numbers represent? Anybody want to take one of the numbers here? Molly, what number you want to take?
The 58.
Okay, the 58. It's totally on the outside of the circle. So what's the 58 mean?
People that don't like either.
Yes, neither. Neither mustard or yogurt. And I have no idea whoever made this one up. Why these pairings here? But whatever. Neither mustard or yogurt. All right. Any other numbers? Sarah? Oh, yeah. 33. Hopefully not together. 33. Like both. All right. How about the 22?
Mustard likers.
Only mustard. No thanks to the frozen yogurt. Only mustard. Freaks. All right. And then the 87. Only yogurt. Frozen yogurt.
Imagine having mustard flavored.
Let's not put that in our minds.
Oh, I'm gonna do it.
All right, let's go then. So let's find the probability. Likes frozen yogurt, but not mustard. I think we know that already, don't we? Likes frozen yogurt, but not mustard. How many of them do I have up there? I have 87 people out of, well, yeah, that's not here anywhere, that number. That's something I got to figure out. Add them all up. There's 200 people in this Venn diagram. Yep. And it cannot be reduced. All right, I'm going to get a couple people on this one. All those surveyed, what's the probability they like mustard? They like mustard.
Would that include the ones in the middle who like both?
Well, let's talk. I know 22 do. But so do
33.
the other 33 because they like both, including mustard. So I just can't have 22. It's going to be 22 and 33. I think it's 55.
Yeah, it's 55.
55 out of 200. And that reduces down to 11 over 40. And here's where we'll end it with another given. The person likes mustard. Everybody stop. We already know they like mustard. So we ain't going out 200 don't like mustard. What's this going to be out of? Given they like mustard. Oh, so that's the 55 people that like mustard. Out of those 55, how many also like frozen yogurt out of those 55? Out of these 55, how many also like frozen yogurt? The 33 in the middle, correct. And I believe we can reduce that 3/5. All right, do me a favor. Grab your Chromebooks. Let's get them out. And let's make sure we're on Google Classroom and not other classwork. For anything, listen please, for anything that's on a table or Venn diagram, I would draw out all your possibilities like we did with the H1, T1, etc. Draw them all out if it's not a table or a Venn diagram. Okay, so let's go. Get on Classroom. Let's get the answer key 5.1 open. And let's get to work. There's plenty of practice here today. For some reason, if yours doesn't match mine, call me over. I believe they're all correct on this one, so we should be good to go.
What's a fair die?
A fair die?
It's a die.
It's your six-sided die. Here's why I got to put the word fair, Sarah, because every once in a blue moon every year I get the kid, well, what if it's loaded to one side and it's always going to 4 on 4? Yeah. And then I just say, get a life, move on with your problems. So that's why it says fair coin and fair die. It's not heavy on one side. Let's go. I'm going to walk around and hover. If you cannot figure out why it is on the answer key, call me over. There you go. There's a third of the unit right there.